Code day number 10. I'm Liz the Gray, and I have been live streaming Advent of Code puzzles since 2017. This is my third year now of live streaming Advent of Code. I've also completed Advent of Code since 2015, the year that it launched. So we have 1 minute before the puzzle unlocks, so I'm just going to go ahead and get my development environment ready and so forth. So let's quickly tab over here. And do that. All right. So puzzle unlocks in 30 seconds, then we'll do a quick speed read of it, and then we'll figure out what we need to do to implement it. All right. Where did I happen to put my cell phone? Oh, I do not have my cell phone on me. Well, that's unfortunate. Not going to be able to look up much else while I'm on here. All right, puzzle. And locking in 4, 3, 2, 1. All right, let's have a look. 502 bad gateway. Poor Eric's servers. All right, we need to monitor the asteroids. Asteroid can detect any asteroid to which it has direct line of sight without asteroids that are nearby it. Yep, okay. Got it. So I need to evaluate line of sight for each asteroid. It's probably too expensive to do this for every pair of asteroids. Instead, I should... wait a second. Oh, I see. I need to walk in every possible direction. But things only block if they're exact multiples away. All right. Well, let's try it the naive way and see whether that works or not, and then we'll go from there. How about that? Let's do it. Hey, 9. So let's paste my nice, lovely puzzle input here. Let's see. This is probably closest to day. All right, so we need something vaguely like this. So we'll just do that like this. Oops. No, of course not. Of course it's not going to work. And so we don't need strconv I to A. Okay. Let's see. So I guess I'm going to use row column again. All right. And then C. Okay. And let's do our standard class. Okay. Finally, we need okay. There's actually not that many asteroids. It actually wouldn't be too complex to brute force it, so that's fine. So make grid. Okay. Then asteroids chord is true. Let's just double check that this is correct first. All right. Nope. Don't need sum. Where did I declare sum? Okay, there. All right. Cool. So does that correct? Let's look. All right. That looks roughly order of magnitude correct. This is what? This is 21 wide by, yeah, that makes sense that it's roughly about 303. Okay. All right, so let's test this now. All right. Something like this should do it. Cool. Let's just do the standard boilerplate while I think about how to efficiently encode the what's blocking what. Okay. And I also need a all right. So let's see. I need to compute the deltas. Let's do row comma colon instead. Okay, so things have a multiple, then okay. All right, and then we need a least common denominator. Let's see, how do I do, does Go have a LCD algorithm? I don't think it does. Okay. All right. All right. I think something like that should do the trick. So now I just need an LCD algorithm. All right. So Okay. Something like this. And then now I have to figure out the numericals. So I need to make sure that I preserve the minus and plusiness of this. So this is strictly operating on the numbers. Okay. So is this the correct way to express this mathematical concept? I'm trying to figure out what the trying to normalize is. Something like that. All right. I'm just writing out what my test cases are going to be. All right. All right. Well, we don't have to do this very often. Let's just do it the stupid way. Let's see. How do I handle this? Huh. So let's just write out the silly way, and I'm sure there is a better way of doing this. All right. I think that's a silly way of doing this, except for I need a prime sieve generator. You know what? Let's see. What's in the Golang math package? There is... No, it's just maxes, mins, remainders, rounds. Yeah, I think I'm pretty much stuck. Oh, but there is... yeah, what's GCD Euclidean algorithm? Euclidean algorithm... How does the Euclidean algorithm work? Two non-negative remainders. Oh, God, it's been way too long since I did this. Oh, I see. Subtract multiples until the remainder is less than n. Okay. Yeah. Okay. Now we're doing this a smarter way. Okay. Okay. Yeah, I should just relearn the Euclidean algorithm. That's what I need to do. Okay. 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 That's fine. I think that should work okay. Okay, now. Yeah, I know. And we're going to handle the absolute values here already. We need math. Okay. Okay. Okay, so so we have the remainder. And then we continue shifting. Let's see. No. Okay, and I do that until the last remainder is 0, at which point okay. I think that does the trick if I understand this algorithm correctly. So in multiples, yeah, so that's going to be lesser. Okay, I think that works. So let's just check this. Grumble, grumble. Where's offsets? Oh. That is grid. Make grid. Okay. I hate goes casting. Okay. Something like this ought to do it, and this makes me very enormously unhappy, but so it goes. Integer divide by 0 at line 84. Oh. Oh. Right. Still dividing by 0. Oh. Right. Okay. Oh, and we need to also exclude ourselves. Okay. Fine. I need to know what sign this is. Which is done this way. Get that red number parentheses right. Okay. But this should never be the identity, so that's fine. Okay. I think that should do it. I think this looks something like this. Okay. I have no idea whether or not this is correct, but we're going to give it a shot. Correct. Rank 252. What the heck? I'm not even that fast. Okay. Continue to part 2. Vaporize with a giant laser. Same asteroids that can be detected can be vaporized. Yep. Okay. Which one will be the 200th asteroid to be vaporized? Okay, fair enough. So, yeah, I know. I'm very, very surprised by this. I feel like I made a number of obvious mistakes, including literally re-implementing the Euclidean algorithm in code. Okay, now we need to vaporize. Okay. All right, so essentially need to come around. Okay, I know how to do this. So we essentially need a what's it called? Theta. Okay. I think that will work. And then we need yeah, that's fine. Okay. So I need to define these up here. Oh, and I'm starting from my monitoring station. Okay. Great. So now that I know our station chord, okay. Okay. Yes, I can. Yeah, that's fine. Just format this real quickly to get rid of all those extra tabs. Where did I muck that up? Line 65. Line 65. Oh, I see. All right. Where else did I? Oh, I mucked it up here as well. Asteroids. All right. That's fine. So, let's see. This is okay. It's by theta. Append asteroids by theta. Okay. And I also need to make sure that that's only happening once. Okay. All right. Let's append k to thetas. All right. Now I need to apply a sort function. And that takes, what's the standard template? So to sort a Go array, we need to have length, swap, and less. Okay. Okay. Oh, that's not even that. Okay. All right. So if I want to swap two of these, that's just this. Finally, I need to write the compare. All right. Right. All right. And we finally need also a method to compute the theta. Okay. And that's going to be a float 64. Oh, actually, this can just be, I can use the sample code here. Where's the by? When did Go change this? Yeah, okay. Length swap. Okay. Should do it. All right. Now, I need to call, let's see, this is going to involve the math package. So if I'm thinking about this, I need to compute the angle between, let's see. Oh, nice. Go has copy sign. I didn't realize that it did. But okay. Let's see. How do I create the? Let's see. So let's feed it some sample inputs I might expect. If I feed it up a row, but no change in columns, that should be a theta of 0. If I feed it a theta of rotates clockwise. Yep. So, okay. So this should be, if it's same row, one column off, then it should return pi or pi over 2 or 90 deg. -1, 0 should return. That should return pi, 180 deg. And 0, -1 should return 3 pi over 2 or so many deg. Okay. So how do I compute this? Ay. Okay. So this means trigonometrically, I should be able to divide, except for the cases that I cannot divide. Okay. I think I understand. So let's see. If when I need to return, do I have math pi? Yeah, I have pi. Great. Okay. 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 And I believe that I am now taking the tangent, arctangent of, oh, I just needed ATN 2. Okay. ATN 2 of, let's see, 1, 0, needs to return 0. Okay, so think 1, 0, return 0. -1, 0. I'm looking at the Go documentation. -1, 0 returns. Yep, okay. I think that should do the trick. Let's just check what the simple input does. I think that's fine though. Okay. I knew that this was in fact in the Go library somewhere. Okay. Okay. So yeah, I'm not going to finish by the time my friend's talk starts. I'm going to have to be just slightly late to our talk, which is a bummer, but so it goes. Okay. So okay. Let's see. So we need to sort. How do I sort? I need to run sort.slice. Oh. Well, damn, that could have saved me some effort. Sort slice. Thetas. All right. Let's get rid of that then. And do this instead. I think something like that. Yeah. Okay. 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 He does. All right. All right. All right. Oh, I need this. Okay. Theta index starts at 0, as it should. All right. Now then I need to. Okay. And then theta is greater than theta's. Theta index gets set back to 0. All right. All right. Now, okay. Greater than 0, then break. Okay. Ah! What did I do wrong? Line 22. Oh, whoops. Line 94. Okay. Line 103. Oh, whoops. Okay. And I need push and pop operations, I think, which do exist. So I need to pop from the top of it. Oh, but I needed to also sort this by distance. All right. So we need to do this. 1 second. Let me just leave a note to myself to do this. Also sort by distance. Okay. All right. Now I need to just pop from it. Okay. I think that should do the trick. Cool. I think that should do it. And then so I know this is going to yield incorrect results because it's going to pop them in the wrong order, but I'm just going to make sure that this compiles first. Line 80. Oh, whoops. All right. Cool. All right. And that needs to be contain a distance. All right. Line 83, that has to be a slice. Oh, whoops. All right. All right. And I need to actually append the, okay. Okay. Feel pretty good about that. So I also need to okay. Okay. I can just use Manhattan distances here because they're all just multiples. Okay. Okay. Cool. All right. Okay. All right. Cool. Manhattan distance should be fine here. Except for that's wrong, line 92. Oh. That needs that. Okay. All right. Import sort. And 994. Theta is pen, theta is k. Okay, that's fine. And line 110. Asteroids by theta. Theta. Theta is theta index. Yep. Okay. All right, that should do the trick. No new variables declared. Yeah, that's fine. I thought I'm declaring destroyed for the first time. But okay. Where is destroyed created? Fair enough. Nope, destroyed is not new. Oh, I see. So this actually won't let me do that. Fine. Declare that separately. All right. I think that should do the trick. All right, let's check this theory by running it on a test input. Day 10. All right. So that destroys in order the one at 0, 1. Wait a second. Let me check that. Okay. Oh, I see the problem here. I need to increment this here. Okay, I think that should do the trick. Yeah, okay. All right. I think that should do it. And now this should complete. And it will spin forever because it fails to find anything to destroy. That's more or less correct. Let's just run this. Okay, so I think this is probably y coordinate is 6, x coordinate is 14, I think. So let's try that and see whether that answer is correct, and then I'll tidy it up. And if not, then I know that it's wrong. Okay. 1406. That is not correct. Okay. It's possible I formatted incorrectly. Okay. Let's try the large example given earlier. So let's try this. Oh, it's just confused by the X. That's why it's not happy with taking that as an input. Okay. And that destroys 200th asteroid is, okay, let's check that. So on the simple, let's check it, day 10, yep. Okay. Let's make sure that that's correct. So it destroys at 110. Okay. Is my where is my monitoring station deployed? Let's see. Okay. I need the X and the Y. So it agrees or not. That's visible from 1113. Okay, that's fine. Okay. Set algorithm is correct. Okay, so now we go through each asteroid. Oh, that actually should be, I see. And that shouldn't have been predefined. Okay, is that any better? No, it's still destroying 110 first. Why is it thinking that 110 needs to be destroyed first? Oh, because I'm sorting maximally by distance. That's why. did that do anything? This is still destroying 110 first. Why is it picking 110 first? Okay, so we've normalized this. Okay, let's make sure everything. Let's print out some of these theta indexes. All right. Okay. All right. Let's see how that goes. Okay. And that is, I need the theta. Cool. Okay. Ah, that's not right. Oh. Right. Oh, I see. Problem is I'm not starting from theta of 0. Okay, I see my problem. Okay, so this was actually correct here. The problem was that I started from the wrong point. Okay. Cool. Okay. Okay. Now we do a stupid search. Okay. So I need to start from 1, 0. Then index equals I break. 100 is off. Okay. There we go. Okay. So now it's destroying 14, 11. Oh, that's just reversed coordinates. That's fine. So column, comma, row, because X, Y, yep. Okay. So it destroys 11, 14, but All right, let's read the puzzle again one more time. Where am I? Okay. So I shoot upwards. Oh, which has a lower row number. Oh. Okay. Ha 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 ha. Very funny. So I actually want, that needs to be inversed. Yeah, that needs to be inverted. Okay. I think that does it. Okay, because it's shooting upwards, which has a offset of -1, yep. And then it swings around and shoots clockwise, which is going to be 0, 1. Yeah, okay. So -1, 0, 0, 1. That might not be right. Let's try that. Okay. 1, 0, and then 0, -1. All right, let's try that. Okay, am I shooting in the correct order now? Destroyed 11, 14, 12, 19. Nope, that's not quite right. Okay, I think I had it right the first time. Okay, let's try that. Destroyed 11, 14, 12, 1. Nope, that's backwards again still. Shite. All right. Is that correct? Oh, I see. No, my bug is here. I found it. Okay, this is correct here, but this is wrong here. I need to look for the initial. Yeah, okay. There we go. Destroyed 11, 12, 12, 1, 12, 2, 12, 4. 200 destroyed asteroid is at 8, 2. Okay, now that's correct. Okay, I think it's then 8, 6. That's now the 200th asteroid destroyed. So let's try feeding 806. And that's correct. Rank 277. What the heck? I don't understand how I'm scoring this well. This is not entirely justified. I feel like I'm taking way too long on these. Okay. Cool. Let's just tidy this up real fast. All right. That all feels fine. I mainly just want to just record the last result. If I equals okay. Okay. Fine. Okay. To print, debug, output. Okay. then iterations. And we'll by default run 200 iterations. How many iterations to run? All right. Oh, whoops. Int and iterations sound like each other. There we go. All right. Okay. Inputs, day 10, simple, go. Up. Input. Oh, there's actually a bug in my code. It's failing to appropriately deal with not being able to fire at something. I'm going to solve that later off camera because I have to get 25 minutes late to my friend's talk. So take care, folks.